Trust is a weird thing. You type your bank password into a website, hit enter, and just hope it hops through a dozen networks you've never even heard of and arrives at the right place. You can't verify this. You don't even try. 5 billion people every day handing their most sensitive data to a system they've never actually seen. And honestly, that trust usually pays off until one typo made 2,000 networks go dark. It's April 1997. You're a network engineer at a small internet service provider in Florida called 𝐴𝑠/7007. You provide internet access to about 200 people, small town customers, mostly homes and local businesses. You handle everything: routing, support tickets, the blinking light on rack 3 that nobody else knows how to fix. It's early morning. You've got a config change queued up, routine stuff. You've done this 100 times. You push the update, take a sip of coffee, and check your monitoring dashboard. Something's off. CPU usage is climbing. Not the slow creep you'd see from a traffic spike. This is vertical. Your router is announcing 51,000 routes to the global internet, including paths to the Pentagon, NASA, Bank of America, routes you don't own, routes your hardware can't physically handle. A bug in your router software just triggered a deaggregation event. It took the entire global routing table and shattered it into 51,000 tiny pieces. And now, every network starts sending their traffic straight to you. Within 3 minutes, traffic meant for some of the most powerful networks starts funneling into your little provider. And to understand why the internet just accepted this, you've got to see how routing actually works. When you send anything online, your data hops between what are called autonomous systems. These are independent networks, each with their own ID number. ISPs are autonomous systems. Cloud providers, governments, banks, all separate networks, all connected through a single protocol called BGP, the Border Gateway Protocol. BGP's job is simple: share directions. One network announces, I can reach Google in 3 hops. Send traffic through me. The next router passes that along. Then the next, like a game of telephone. No password, no cryptographic proof, just a claim, broadcast across the internet, and routers update their tables immediately. Okay, you're probably thinking, surely there's a verification step somewhere. There isn't. Engineers built this protocol in 1989. About 200 networks existed online. Universities, research labs, colleagues. So building a verification system would have been unnecessary because everyone knew and trusted everyone. So they built BGP to share directions with speed and efficiency between friends. The internet now has 74,000 networks, and BGP still works the same way. So when that Florida router announced 51,000 routes, nobody questioned it. A major backbone saw a shortcut through your tiny ISP and started redirecting global traffic toward it. Traffic meant for the Pentagon, NASA, Bank of America, all funneling into a provider that serves 200 homes and runs on hardware you could probably outperform today with a decent laptop. Back in Florida, your router's CPU is pinned at 100%. Memory buffers are overflowing, packets are arriving left and right faster than the hardware can process them. You're watching your dashboard light up like a Christmas tree. There's nothing you can do. You try to pull the announcement back, but BGP doesn't have a recall function. Once a route propagates, every router that accepted it has to time out on its own. 2,000 networks go dark. Banks freeze mid-transaction. Email systems collapse. And international calls cut out one after another, while you sit there for 45 minutes waiting for the internet to sort itself out. That one typo cost up to $2 million in damages. Engineers call this a route leak. When a network accidentally announces routes it doesn't own and the internet casually passes them along. BGP doesn't have any concept of trust. It was built for a world of 200 friends, so it assumes that if a neighbor tells you a path exists, they're not lying. If Verizon's neighbor says it can't reach your 200 customer ISP, Verizon just accepts the announcement. That's the entire verification process. There isn't one. Right now, over 950,000 of these unverified routing entries sit inside a single backbone router. Every time you log into your bank, your password hops through a dozen of them. Your medical records pass through networks that accept announcements from anyone. There's no alarm when a suspicious route shows up. It's just quiet. 1997 was an accident, a costly accident nevertheless. What happened in April 2010 might not have been. For 18 minutes, China Telecom's routers announced routes that pulled 15% of worldwide internet traffic through Chinese networks. That includes US government communications, military data, and defense contractor files, all briefly flowing through China Telecom infrastructure before reaching its intended destination. China Telecom said it was a misconfiguration, but US intelligence agencies weren't so sure about that. This wasn't just a detour. The traffic didn't just die all of a sudden. It flowed through Chinese infrastructure, got inspected, and then was handed back to the original destination. To the person checking their email or logging into a government portal, everything looked completely normal because it was invisible. When someone does this on purpose, it's called a BGP hijack. Same mechanics as a route leak. The only difference is intent. And BGP genuinely can't tell the difference. An intentional hijack and an accidental typo produce identical signatures. The protocol has no mechanism to detect which one is which. Espionage and incompetence leave the same fingerprint. It's the perfect setup for deniability because the protocol was never built to ask questions. In 1997, the internet had about 70 million users. When 2010 came along, almost 2 billion. Everything stayed the same. Just a lot more people were depending on it. We actually have a fix for this. We had it since 2008. It's called RPKI, or Resource Public Key Infrastructure. Digital certificates that cryptographically bind an IP address to a specific network ID. A router checks the certificate, verifies the signature, and only then accepts the route. As of 2026, about 75% of all global internet traffic is finally signed. That sounds like progress until you realize a quarter of the world's data is still traveling on the honor system. But why isn't it 100%? Well, small ISPs don't have the hardware to validate thousands of cryptographic signatures per second. Their routers weren't built for it. Large providers like Verizon prioritize keeping traffic flowing because rejecting an invalid route also risks rejecting legitimate traffic during the transition. Better to stay vulnerable than deal with an avalanche of angry customers wondering why their Netflix stopped working. And then you've got the geopolitics. Some countries don't trust US-run certificate authorities making decisions about their routing tables. China builds its own parallel systems while Russia pushes back on adoption. The decentralized internet starts fracturing along political lines, which is ironic since decentralization is the whole point. Compare that to patching a vulnerability on your own server. You patch it, done. Your system's safer. RPKI only works if everyone uses it. One network that skips validation can still accept and propagate a fake route. 17 years we've had the cryptographic fix, but coordinating 74,000 networks simultaneously is exactly the kind of problem the internet's decentralized architecture was designed to prevent anyone from solving. In 1998, a year after the Florida incident, 7 hackers from a group called Loft, or 𝐷cie𝗶ဖိ, rented a 15-passenger van and drove to Washington. They walked into the Dirksen Senate office building and sat down in front of the Senate Committee on Government Affairs. The chairman read their names onto the record. Then he paused and said he hoped his grandkids never asked who his witnesses were that day. 𝗔, the man who would later become the head of security at Twitter, looked the senators in the eye and told them, actually, just one of us, with a few packets, could make the internet unusable for the entire nation. He was talking about BGP. That was 27 years ago. 27 years running, and the protocol hasn't changed.